Alright everyone, so here we have the first one. An escalator in an underground station has 250 people standing on it, and it is moving with a velocity of 4.3 meter per second. The average mass of a person is 78 kilograms and the angle is 40 degrees with the horizontal. We need to find the minimum power required to lift these people. So the first thing is you can write down the formula of power, and P equals to, in terms of force and speed, we have this relation for power. P equals to F into V. Alright, so now we need to find the value of the force that would be used in order to lift the people, of 250 of them. So if I try to draw the diagram of the situation, it would look something like this. Yeah, something like this. And then the angle with the horizontal is 40 degrees. The persons, the people, all 250 of them would be going up the escalator in this direction, and we need to find the force that would be used to push the all 250 persons up the escalator. So one of the force that we know would be the weight of the people, and that weight W, that equals to mg. So I can write mg over here. But then what is the weight of 250 people? What is the value for the weight? So let me first find the value of weight for all 250 people. All right, now we can hit it on the calculator. Okay, so this is what we have as the weight of all 250 people. And then you realize this thing as well, that the escalator is moving with a constant velocity. So it is moving with a constant velocity, and you need to apply a certain force to keep it moving with a constant velocity. And once we have that value of that forward force, we can insert that force in the formula of power, and we can multiply it by the velocity, we can multiply by the speed, and then we can find the value of the power. But what is that force that we need to apply in order to make those people move up the escalator? Now we know this thing. Okay, we studied that in theory, that the component of weight, this is mg, the total weight, which is 183938 newtons. This is the total weight of 250 people, but only one component of that weight is responsible to bring those people down the slope, and that would be mg sine theta. So mg sine 40. Okay, the other component, mg cos theta, that is balanced with the normal contact force. I'm not going to draw that triangle over here, but we study that in theory, that the component of the force, the component of the weight that would be responsible to slide the object downward is mg sine theta. So we need to apply the force equals to mg sine theta to make these people move up the escalator. So what is that force? Mg sine theta. So we do have the value of mg for all 250 people. So let me first find the value of mg sine 40. So I just multiply the answer by sine 40, and what I get is 1229. All right, so in order to make the object, in order to make the escalator move with a constant speed or constant velocity, I need to apply, or the escalator need to apply, the same force but in the forward direction, and that would be the force which in magnitude would be equal to this force, mg sine 40. So the value of mg sine 40 is the force that we need to provide, but in the forward direction, so that the people on the escalator can move with a constant velocity of 4.3. So what is the force? 122,962. And if we multiply by the speed, which is 4.3, we can find the value of power. So let me multiply by 4.3. We get 528,736 watts, which can be written as 530 kilowatts. So for this one, C is the right answer. Alright everyone, so here we have the next one. The car of mass 1400 kilograms traveling on a straight horizontal road at a constant speed. Okay, so means the forward force and the backward force should be equal. The net force should be 0. The output power from the car's engine is 30,000 watts. We can write 30,000 here. The car travels up the slope at 2 degrees to the horizontal, maintaining the same speed. What is the output power of the car engine when traveling up the slope? And previously, the power of the car engine was 30 kilowatt. And just before we answer the question, before we find the value of the power in the second case, in this one, let me ask you the question. Would this time the value of power, output power of the car engine, should it increase or decrease? And if you think it should increase, that is the right answer, because now you have to travel up the slope, so you have to do some work, extra work against the gravity as well. So against one of the component of weight, you'll be doing some work. And what component of weight would that be? We studied that already in dynamics in the inclined plane, that the component of weight that brings the object, or that tries to bring the object down the slope, is mg sine theta. And what about mg cos theta? That is equal, and that cancels out with the normal contact force. Okay, we draw the vector triangle of this thing, and we study that in topic of dynamics in the inclined plane. Okay, so let me first find the forward force of this car in this case. So the forward force, let's call it the driving force. We can call it FD. So the driving force would be, since you know the formula in terms of the force, pressure, and the relation between the force, pressure, and force, power, and speed is P equals to F into V. We are given with the value of output power, so that is 30,000. So we can write 30,000 as the value for P, times the force, the forward force we need to find, F driving force we need to find, and the speed is 25. So if I hit it on the calculator, what I get is 1200. So the driving force would be 1200 Newton. Alright, and let me ask you the next question. If the driving force is 1200 Newton and the object is moving with a constant speed, what is the frictional force? And the answer to that question should be the frictional force, let's call it small f. The frictional force should be exactly the same, but that would be in the opposite direction. So the frictional force would be 1200 Newton, and that equals to the driving force. Only then we can be moving with a constant speed. If the driving force increases, we get a resultant force and we'll be accelerating. If the driving force is less than the frictional force, there is the resultant force in the backward direction and we'll be decelerating. But in order to maintain the constant speed, these two forces should be equal. Now let us study the second case. So that means as you travel up the ramp, a component of weight would be responsible to drag it downward, to bring it backward, down the slope. and that mathematically equals to mg sine theta. Okay, we studied that topic in much detail using the vector triangle in the inclined plane. So mg sine theta would be trying to drag it downward, and there's another force that we calculated, which is the frictional force. So if the vehicle is moving forward, the friction force would be backward, and the value of friction force would be same, which is 1200 Newton, because we're moving with a constant with the same constant speed. So the friction force, it depends on the speed. If you're moving with the same speed, our friction force should be same, and the forward force should also be the same. All right, so the forward force in this case, which is F driving force, needs to be calculated, and once we have the value of the driving force, we can multiply by the speed, we can get the power. So now you can think about this question in different ways. One of the way is just take a look at the direction of the force vectors. How many vectors do you have? You're moving with a constant speed. Okay, keep it in mind. We are moving with a constant speed. So that means the backward forces and the forward forces along the ramp, in the direction along the ramp means in this direction, the forward forces and the backward forces should be equal. So what is the sum of forward forces? Well, it is Ft, because we have only a single forward force. What is the sum of the backward forces? Well, it's going to be mg sine theta plus the frictional force. So what is the driving force that we need this time around? It should be greater than 1200, because we have to compensate not only for the friction we have or air resistance, but we have to compensate for the component of weight that will try to drag the vehicle down the ramp, which is mg sine theta. So what is mg sine theta? The mass of the car is 1400, so 1400 times 9.81 times sine 2. This is mg sine theta plus, what is the value for the force? Well, the friction force would remain the same, which is 1200. So if I hit it on the calculator, I'll be getting, let me just hit it on the calculator. Alright, so this time around the force is increased from 1400 to 1679. So 1679 newtons. This is a force that you'll be needed to provide through the engine in order to make it move up the ramp. All we gotta do is to find the output power. So power equals to force into speed. We can hit it on the calculator, whatever the answer was, times 25. 41975. An aircraft travels at a constant velocity of 90 meters per second in a horizontal flight. The diagram shows the horizontal forces acting on the aircraft. The mass of the, okay, so we need to find the power produced by the engine, the power produced by the thrust force. So P equals to, we write down the formula of power in terms of the force and speed, is P equals to F times V. So what is the forward force that that needs to be there, since you're moving the constant velocity? And the frictional force or the air drag is 2400. So the thrust has to be 2400 as well. So whatever the backward force is, the same has to be the forward force, and whatever the downward force is, the same has to be the upward force. But we're just looking at horizontally, because we need to find the power produced by the thrust force. So the upward and downward forces are balanced, and the backward and forward forces would be balanced. And what is the force that is produced by what is the thrust force? That would also be 2400. So 2400 times the velocity or the speed, which is 90. So if I hit it on the calculator, 2400 times 90, 216, 1 2 3. Okay, uh I missed out the options. The options are um, cropped out, but it would be B from the question, in which the answer is written as 2.2 into 10 to the power 5. So it would be the option B from the past paper, which is written as 2.2 into 10 to the power 5 watts. Okay, so if you convert it into 2SF and you write it in scientific form, so it'll be 2.2 into 10 to the power 5 watts. Alright everyone, so let's check out the next one. A constant force F acting on a car of mass m moves the car up the slope through a distance of s at a constant velocity v. The angle of the slope to the horizontal is alpha. The acceleration of the free fall is g. What is the ratio of gravitational potential energy gained by the car divided by the work done by the force? Okay, so it's quite kind of a simple one, but with bit of a catch here, which is the gravitational potential energy equals to mgh, and the work done by the car would be force, whatever the force is in the direction of the motion, times the displacement covered in the direction of motion, or along the line of motion. So what is the value for the gravitational potential energy? So we need to find the value of GPE divided by WD, work done. So GPE equals to mgh, but we don't have the vertical distance that we call height, so we don't know how much height is gained by the object. So if you check out the answers in the numerator, which refers to the gravitational potential energy, all the options are in the form of, in the terms mass and sine alpha and v. So it means you need to convert the height into some other variables. So if you consider this right angle triangle, then what we can say is this angle, for this angle alpha, sine alpha, this is your height, sine alpha equals to perpendicular over hypotenuse. So sine alpha equals to perpendicular, which is height, divided by the hypotenuse, which is, in this case, the hypotenuse is s. So we can rearrange h in terms of s and sine alpha, and h equals to s times sine alpha. So what is the gravitational potential energy gained by the car? mg, and height in terms of the other variables is s times sine alpha. Now divided by, what is the work done by the force? Well, we do have the value of force, and luckily we do have the value of distance covered in the direction of force, which is F into S. So we can do some cancellation here. This has cancelled out by this one. What are you left with? You're left with mg sine alpha divided by F, which is D. So D is the right answer for this one. Alright everyone, so here we have the next question. The description can be seen from the diagram as well. Let me read the question first. The magnitude of the total resistive force acting on the car is 2000, once again given in the diagram. What is the power output of the car engine? So as you're moving down the slope, your engine is still on, and the engine is still applying the force. So you're providing a forward force as well. So sometimes what we do is, if you're going down the slope and the slope is significant, then we might want to shut off the engine as well, turn off the engine as well, and no force would be produced by the engine. The entire work would be done by a component of weight that tries to bring the object down the slope, and we have said it repeatedly, the component of weight that tries to bring the object down the slope is called mg sine theta. So one of the component of weight would be there, which would try to bring it down the slope, and we call it mg sine theta. Mg sine theta in this case is 6.0 degrees. Alright, so since the engine is also providing a force, which is a forward force, which is down the slope, and that force would be P equals to Fv. We have to write that force in terms of power. P equals to Fv. Alright, so for the timing, let me call that force the driving force, Fd, which would be in this direction. This is your Fd, the driving force. And then there's another force, which is resistive force, which is against the direction of motion. So how many forces do we have? We have the driving force, we have a component of weight that is down the slope, down the ramp, which is mg sine theta, and the third force is the resistive force. And if the vehicle is moving with a constant velocity, then you have this thing, sum of forward forces along the ramp equals to sum of backward forces along the ramp. What is the sum of forward forces? Force number 1 plus force number 2, which is the driving force plus mg sine theta. So see, this time mg sine theta is in our favor. So it's being added with the driving force, because now we have to go down the ramp. In the previous examples, we were going up the ramp, so the mg sine theta was actually going against us. So engine had to do some extra work in order to compensate for mg sine theta for that force. So in this case, the sum of forward forces is Fd, driving force, plus mg sine theta, and that equals to the sum of backward forces, which is only a single one, that is the resistance or the friction. So let me insert the values. Fd, we don't know the value of it, plus mg sine theta. Mass is 1500 times 9.81 times sine 6 equals to 2000. So let me find the value of Fd from here. Here is 461.86 Newton. Now we can find the power output of the car engine simply by multiplying this driving force, which is the force of the engine, with the speed, which is 30. So whatever the answer was, 461 point stuff times 30. So answer times 30, we get 13855, so 13,000 watts, 13.8 thousand watts, which into SF would be 14,000 watts. Alright, so let's move on to the next one. What is the work done by the force on the object as it travels to the point X? So this is your starting point, we can call it W, and the ending point is X. So what is the force that is being exerted at the point W? At the start point is 2.1 Newton, and we need to find the work done as it moves from W to X. So work done equals to force, the product of force, and the distance covered in the line of force. So the force is for 2.1 Newton, and the distance is 4.0 meters. But the only problem is the force and the distance, they are not in the same line. That is the only problem. So what you can do is you can convert the force, and matter of fact, you can even convert the distance. But let me convert the force. So the force is 2.1 Newton in the forward direction. This is the force, 2.1 Newton. You can draw it anywhere, but the direction has to be same. And if you want to keep the length the same, would be better. So 2.1 Newton, forward direction. So I'm going to convert this force into two components. I'll draw one of the component on this side, that's totally your choice, and the other component perpendicular to the first one. So what is the upper component? If this is 2.1, the force is 2.1, then the upward component that is in the direction of 4 meters, that component would be F cos theta, because that is there directly with the angle. And the other one would obviously be F sine theta, but we don't need to do anything with it. All we need is to find the component of force that is in the direction of the displacement. So it would be F cos theta. So we don't use the entire force 2.1, we only use F cos theta, a certain component of it, and the distance or the displacement is 4.0. So what is F? F was 2.1 times cos 30 times 4.0. Okay, then you hit it on the calculator and you'll be getting C as the right answer. Okay, you can just check it out by yourself. You'll be getting C as the right answer, 7.3 into SF. Okay, here we have the next one. So that is kind of an easy one. Generally in this video I was trying to add some of the tricky questions, but let's just go through it anyway. The total energy input in a process is partly transferred to useful energy output U and partly transferred to the wasted energy. So the total energy is input and the useful one is capital U and the one that is wasted is capital W. What is the efficiency of the process? So simply we need to find the efficiency. So efficiency equals the useful output divided by the total input, which is I in, and if you want to find in percentage, you can write 100% with it. You'll be getting the answer in percentage. So A has to be the right answer for this one. So ladies and gentlemen, here we have the next one. An escalator is 60 meters long and lifts passengers through a vertical height of 30 meters as shown. The escalator, to drive the escalator against the forces of friction when there are no passengers, require a power of 2000 watts. Okay, the mass of each person is 60 kilograms and we need to travel with a constant speed of 0.75 meter per second. It is carrying 20 persons, and what we need to find is the power that is required to drive the escalator. Okay, so the thing is that power equals, once again, the power that is required to drive the escalator forward is equal to the product of the driving force times the speed. P equals to FV. What is the speed? 0.75. Okay, we can write it down quickly. And then what is the forward force that would be required? That is a big question. And matter of fact, all the working you have to do it for the driving force. You need to find the value of the driving force. So what I can do is I can quickly find the angle, this angle. So you see you're provided with the right angle triangle. So one side is this, the vertical is also given, which is 30. This side is given as 60 and the base is not given. But if you want to find the angle, you're given with the perpendicular, you're given with the hypotenuse, you can find the angle, which is sine theta equals to perpendicular over hypotenuse. So theta equals to 0.5 and sine inverse of 0.5 is, whether you like it or not, but 30 degrees. 30 degrees is the angle of the slope, the angle of elevation, you can say. So 30 degrees. What is the next step? Well, for the driving force, you have to compensate for two things. You have to compensate for the friction, and you have to compensate for another force that would try to drag these persons down the ramp. What do we call that? I've said it several times even today that we call that mg sine theta. So mg sine theta backward, so the FD forward, mg sine theta backward. So what we write here is and also we do have the value of friction as well. All right, so but anyway, let me first find the value of the forward force. So if I find the value of FD, and that equals to like I said, you have to compensate for the weight of the person, because the weight component of weight, which is mg sine theta, would try to drag the people down the ramp. So the forward force has to be mg sine theta. Then you can insert the values. What is the mass? The mass of 20 people would be 20 times 60. That is the mass of the 20 people. Mass of 20 persons. And the value of G is 9.81. Sine theta is sine 30. And you multiply all of this. This is the value of Ft. You multiply it by the speed, which is 0.75. You get the value of the power that would be required to travel it just to compensate for the mg sine theta. So that equals to, in the first part we get 5886 plus, sorry, multiply 5441. Okay, we can do it 4414.5, so it would be 4415 watts. Okay, so this is a power that you need just to drive the people up the ramp, but since there is friction as well, and some of the power is used to compensate for the friction. How much is that power? 2000. So this was a power just to compensate for mg sine theta. But since you have the friction as well, so you need to provide some extra power, which is 2000 given in the question itself. Over here, you can see over here. So plus 2000. What do you get? You get 6415 watts. So it has to be 6.4 thousand watts, aka 6.4 kilowatts. All right, everyone. So here we have the next one. The mass of 40 kilograms is released from a rest from a height of 20 meters above the surface of the planet. The rock has a kinetic energy of 32 kJ. When it hits the surface of the planet does not have the atmosphere, so no energy would be lost in friction or air resistance. No energy loss in friction or air resistance, whatever you want to call that. What is the weight of the rock on the surface of the planet? So on that planet, if we know the mass, you can straight away use the formula W equals to mg. The problem is we do know the value of mass, which is 40, but we do not know the value of the gravitational field strength on that planet. This is not, they're not talking about the Earth. Otherwise, it would have been mentioned. So this is some random planet, and first we need to find the value of the gravitational field strength on that planet. So you see, in this question, there are some energy changes that take place when you were having at a height of 20 meters above the surface. So let's say this is the surface of the planet. You have the mass of 40 kilograms over here. At the maximum point, the energy that the mass has would be the gravitational potential energy. As the mass comes downward just before touching the ground, all the energy, potential energy, would be converted into kinetic energy. There would have been some energy losses, but since we have no atmosphere, so there are not going to be any losses. So we can write down the formula: mgh equals to 1/2 mv square and we can cancel out mass on both sides. So G equals to the gravitational field strength. G is not 9.81. Once again, we are not talking about the planet Earth. So G equals to V squared divided by 2h. And then what is the speed? So for the speed, okay, speed is not given. So let me do it the other way. I'm not going to cancel the masses. So the kinetic energy is given as it is. The kinetic energy is 32 kilojoules. So instead of this whole thing, what do you write? 32,000. So you write 32,000. I'm not going to cancel the masses. So 32,000 times mgh equals to mgh. Okay, so G equals to 32,000 divided by mass, which was divided by G equals to 32,000 divided by mh. The mass was 40 times the height was 20. So 2 zeros cancels out these two, and then we have 4 2s are 8, 8 4s are 32, 8 4s are 32, followed by 1 0. So this is a gravitational field strength on that planet. You can write in Newton per kilogram if you want, or you can even write it as meter per second squared. This is the value of G on that planet. So what you can think about is the planet is a massive one, much bigger than the planet Earth. For the Earth, it would have been 9.81. So almost at least 2-3 times bigger than the Earth. So what we do is we can now use the same formula, W equals to mg, since we have the value for gravitational field strength of that planet as well. So 40 was the mass. What is the value of G? We plug it from here. The value of G was 40 once again. So what do we get? We get 1.6 followed by double zeros, which is 1.6 kilo Newton. Weight is a force measured in Newton.